Hello, my name is Alina and I am going to talk a little about the prototype design pattern in this kinda short presentation that I made together with my team. First of all, prototype is a creational design pattern, meaning that it provides object creation mechanisms which increase flexibility and reuse of existing code. Prototype allows us to hide the complexity of making new instances from the client. This is done by copying an existing object instead of creating it. The existing object, the one we want to copy, acts as a prototype. Moreover, the new object, which is a copy of the prototype, may change some properties. To understand better this type of design pattern, let's think about the following situation. Let's assume that we have an object and we want to make a copy of it. If we decide to create a new object, we have to copy all the values from each field to the new object. Unfortunately, we can be in the situation that some fields could be private and not visible from outside the object, so we cannot create the new object. Also, there are times when we know only the interface the object follows, but not the actual class. Again, we cannot create the new object. Even though we don't have these problems, our code becomes dependent on the object's class, and the object creation can be time-consuming and could cost a lot. So, a solution to this problem is to create a new object by using the clone method on the existing object. This method creates an object of the current class and carries all the values of the old object to the new one. Here you can see the structure of this design pattern. The prototype interface declares the cloning methods. In most cases, it's a single clone method. The concrete prototype class implements here the cloning method, and in addition to copying the original object's data to the clone, this method may also handle some edge cases of the cloning process related to cloning linked objects, untangling recursive dependencies, and so on. The client can produce a copy of any object that follows the prototype interface. The situations when you should use prototype are when the classes are instantiated at runtime, when the cost of creating an object is expensive or complicated, when you want to keep the number of classes in an application as minimum, and when the client application needs to be unaware of object creation and representation. Among the advantages of using prototype design pattern are getting rid of repeated initialization code in favor of cloning pre-built prototypes, producing complex objects in a more convenient way, cloning objects without anchoring them to their concrete classes, and the fact that each copied object is a single instance. The downside of prototyping is the fact that cloning complex objects that have circular references might be very tricky. First example is from Elasticsearch, an open-source distributed RESTful search engine. Here we have the class mock_secure_settings, which implements secure settings, which in turn extends clonable. That is the class that has the clone function needed for creating the aforementioned design pattern. And as you can see, the class is used in internal test cluster. The second example is taken from an open-source Java library that can basically copy any Java object. Here we can see that clone is the copy we will get after using the dip clone method, which shows us the usage of the prototype design pattern.